So we have one last bit in the radical, okay? For the second part, the part B, we'll come back to question B if we still have time at the end, okay? So let's go to radical equation. Right, so equation means you need to find x, right? So for x. But when you get an equation that has radical, then we call that radical equation. If you look at the steps here, first you need to isolate radical. Okay, pretty straightforward. Okay, want to keep the radical on one side, okay? And then square both sides. So what I will do is to make the square root go away. Number 3 is the most important step, okay? You need to check your answer and make sure the answer that you get still works, okay? So here I will explain why sometimes the answer doesn't work. Sometimes you need to throw it out, okay? Reject. So I'll put the notes here, okay? So why check answer. Okay, so suppose you have two equations here, okay? Two different questions. One is square root x plus 1. Okay, make it simple, okay? Equals to 5. The other one is the negative square root of x plus 1 equals to 5. Okay, so can you guys copy this down first? Okay, and raise your hand when you finish copying. Okay, Eric, got it?
Yeah.
Okay, you got to raise your hand, okay? So I know you're done. All right, so let's follow the steps, okay? So first step, it says isolate radical, right? So the equation is already isolated. Radical is on the left side, right? For the both first one and second one. So already isolated. Well, second one is not really, right? You can move the negative to the other side, okay? So step 2, we are going to square both sides. So if I square the left side, okay, so let's do it like this. Right? And then I will square the left side, square the right side, right? Square both sides, that's what it means. And then for the second one, I will do the same thing. But first I will isolate the radical, right? So I'll multiply both sides by -5, sorry, by -1 to get rid of the negative on the left side. And then I will square both sides. Right? I isolate the radical and then square both sides. Okay? So once I square both sides, then the left side, there's no more square root. So it becomes x plus 1, right? And then the right side becomes 25. And you can see that both of them become the same equation. Right? Becomes this one in the green. Right? If I square both sides. And then if I continue to solve this one, right? So x will equal to 24. Then that will be our answer, right? This is our answer. Any questions so far? Okay, so we have found the answer. However, if I try to check, right? I want to check now. and you sub it into the first one, okay? Put it into the question, right? Question is the one that has the radical. So 24 plus 1, and then that's 25. Square root will be 5. So the first one checks. If you put into the second question, 25, right? 24 plus 1 is 25. Square root of that is 20. Square root of 25 is 5. But then there is a negative at the front, right? In the questions. So you will end up with -5 equal to 5, which doesn't equal. So for the second one, it doesn't work. So if the question is like number 2, even though you get 24, then you should reject, right? So both of them ends up with the same answer, but it works for the first question, but it doesn't work for the second question. Okay, does anyone know why? How come? Look at the process here, right? We square both sides and then solve for it, get the answer. But how come the same answer only work for one of the original question? Brandon, what do you think?
Because there's a negative sign.
Yeah, there's a negative sign. That makes it doesn't work.
And you can't square anything to get a negative.
Yeah, that's one of the reasons too. Very good. Another reason is because of the squaring both sides. Once you square both sides, you got rid of the radical, right? And you get a new equation that's green one, the one in the green box. So the answer that you got is actually for the green one, right? You got it from the green. You are pretending the radical does not exist. So like Brendan said, right, radical does not produce a negative, right? So you need to double check, see if it still works with the original question that has radical, because radical has more restriction to it. Okay, because in the in between the steps, right, you sort of change the question so then easier for you to solve, but you just need to check again. Okay, make sure you can keep it. Right, so that's all you need to remember. Okay, the third step, you always have to check, okay, if you can keep the answer or not. So let's try question A now, right? So we isolate the radical, right? We move the 7 to the other side. So that makes a 2 on the right. And then we square both sides. Square and square root cancel out. You get plus x plus 1 equal 4. X equal to 3. Okay, we need to check. When we check, we plug into the question. So we have 3 plus 1 equal to 2, right? We want to see if the left side equal to the right side. So 3 plus 1 is 4, right? Equal to 2. So 2 equals to 2. So it checks. Once it checks, you box your answer. Okay, so once you got this one down, can you raise your hand? And then we are going to do question C together, okay? So let's look at C now. So question C, we'll start by isolating, right? So let's isolate the radical. Radical is right here. So square root of 2x plus 3. We move the x to the other side, so it'll be x minus 3. Sorry, 6 minus x, right? Second step. What is second step, Aaron?
Square both sides.
Yeah, okay. Second step, we square both sides. Okay, so we would have square, square. Okay, on the left side is pretty easy, right? Square root once again disappears. Okay, how do we square the right side? Colin?
Distribute it.
Okay, what would that become?
So 36
Mm-hmm.
minus 12x
Mm-hmm.
plus x squared.
Plus x squared, yeah. Okay, or you could use the formula, right? A minus b squared. Okay, then same thing. Okay, so once you get to here, this equation is no longer radical, right? Not a radical equation. It becomes a quadratic equation. So you have to take out your book one, right? How do you solve a quadratic equation? Okay, Yosher, do you remember how do we solve a quadratic equation?
You can use the formula.
Yeah, and before you, using formula, what do we need to do first?
And check for GCF. Yeah, GCF.
I mean the form, do we just start using it with the way it is right now?
No, you need to like make it to 0.
Yes, okay, we need to turn it into general form, okay? So move everything to same side. So I'm going to move everything to the right side, but then I write it on the left, okay? I keep the x squared positive. So it'll be x squared, I'll move the 2x over, so minus 14x, and then plus 33, right? Equals to 0. Okay, you could, of course, you could use the formula, right? Negative b plus minus that thing, okay? But if you forgot, right, you start with checking GCF, see if we can do the cross multiply factoring, okay? This one should be factorable. Okay, so I'll let you guys try that. Back to this. Okay, and once you found the two answers, please raise your hand. Okay, so Sarah, what are the two answers?
X minus 11.
11?
Yeah. Oh.
And
Oh, wait. 11 and 3.
and 3. Okay, so the factors will be x minus 11 and x minus 3. Right? So we found our answers, right? But remember the answers that you got is the answer for the quadratic equation, right? It's not always the answer for the original, right? This is the answer for that one. So therefore, we must check, right? Step 1 is isolate. Step 2 is both sides. Step 3, you need to check if you can keep it, okay, for the original question. So let's plug the 11. Okay, we'll check the 11 first. So 11 plus 2, right? We plug it in. And then 11 plus 2 times 11 is 22, right? 22 plus 3, 25. Okay. 11 plus square root 25 is 5, right? So that's 11 plus 5. So that's 16. right? 16 is not 6. So 11, you need to throw out, okay? Let's check 3. So 2 times 3 plus 3 equals 6. So we plug in the 3. So same with this one. Okay, so it'll be 3 plus root. Okay, what's inside, Colin?
9.
9. Okay, so root 9 is 3, right? So we can see 3 plus 3, it does equal to 6. Okay, sometimes you can keep both of them. Sometimes you reject one. Sometimes even you reject everything. Okay, so it's not always you check one throughout, the other one works. Okay, you have to check both. So this one, the only answer is x equal to 3, and that's all. Okay. Any questions here? So that's your step 1, 2, 3. So it turns out into a quadratic equation. Okay, we have another harder one. Okay, questions B and D are similar. Okay, so I'm not gonna go through that. The next page. Okay, are you guys ready to move on? Can you raise your hand? Okay, so let's see what happened on the next page. You have more than one radical. Okay, so that's why it makes a bit longer process. Okay, but the steps are the same, right? I did not add any extra step. Still 1, 2, 3. Okay, so step 1, what is step 1, Aaron?
Isolate.
Okay, then we have 2 radical. Which one do you like to isolate then? Pick one, please.
The first one.
Okay, then can you tell me what to write? Yeah, still you.
Root 4x plus 5
Mm-hmm.
is equal to root 2x minus 1 plus 2.
Yeah, okay, plus 2. Very good, okay? So you add it to the other side. So our first radical is isolated, okay? Step 2 is going to square both sides. Okay, how do we square both sides, Colin?
So just square both sides.
So what would it become? Can you tell
5.
me?
4x plus 5
Okay,
equals to 2x minus 1 plus 4.
okay. Very good. Thank you for doing this so everybody can learn from it. So this is not correct. Thank you, okay? It's a good mistake, okay, that a lot of people make. So this is not good. Okay, so I'll show you why. How come it's not good? Let's say if I have 2 plus 3. Let me change this differently. Okay, 5, okay? I'll do 5. 5 equal to 2 plus 3, right? If I want to square both sides, I square, square, square. This is what you did, right? You square everything. So that's why it becomes that. So let's see what happens. On the left side, 5 squared is 25. On the right side, you get 4 plus 9. They don't equal, right? So when you square both sides, you cannot square like that, okay? So this one, make a note, okay? Everybody please write this down. This is a very common mistake. So what will be the proper way to square both sides? instead? Anyone? Eric, what do you think? How do we square both sides properly?
Do you move the other like square root over to the left side?
You mean to the left side?
And then, yeah, so like
Then-
root 4
then it's
x
back-
plus 5 minus root.
Then it's back to the original question. Original question is like that.
Oh yeah.
We cannot square each one like that, right? Otherwise, we would have done that already, right?
Would you multiply it by the conjugate?
We only use conjugate if we want to rationalize. Yeah, this one we won't use conjugate. If you multiply by conjugate, you have to do the same thing on the left side as well. It makes both sides, right, more complicated. But good thinking, okay? Any other? We still want to do square both sides, but how do we do it the right way?
Are you able to square the whole right side with brackets?
Yes, that's correct, okay? You have to square everything. That's the key. Okay, that's usually the part, okay, people missed, okay? Because people always like the easy way, right? The easiest way is just get rid of everything in one shot, okay? But you can't. So on the left side, radical disappear. On the right side, you need to square slowly, okay? Think of a plus b squared, right? So you got to do a squared. That's a squared plus 2ab, so 2 times a times b, and then plus b squared. Okay, does anyone have question about how we get there? Can you raise your hand? Okay, let me know if you understand what's going on. That's the A, that's a B, okay? This is the A, this is the B. Okay, Eric, do you understand?
Yeah, I'm just writing it down right now.
Okay. So once you do this, right, once you square this way, then left side no more radical, right? So the whole equation just have one. Okay? Since you only have one, then you can back to step one. You'd isolate the remaining one, okay? But first, let's simplify a little bit, okay? So 4x plus 5, 2x minus 1, I can add a 4, right? So it'll be 2x plus 3 equal to, and then 2 times 2 can give you a 4. So plus 4 root 2x minus 1. Okay, so once you get to here, you have just one radical. Then you will isolate that one now. Okay, I'm gonna keep it on the right side. Move everything to the left. Be 2x plus 2. Okay, so same thing. Isolate, right? This is step 1. We isolate. Step 2, we are going to square both sides. So you see I put big brackets, right? So remember to square properly. You cannot just square every term. So I'll let you carry out this one and solve for x, okay? Once you got the x, you can raise your hand. So I think you will again get a quadratic, okay? I don't know if it will be factorable, but try it out. Okay, let's check the first step, okay? After you square, you need to use the formula, okay? 4x squared plus 8x plus 4, that's on the left side. Right side, you need to square, meaning times itself, right? So 4 times 4 will be 16. Square root will disappear. And then turn it into general form, okay? It will be a quadratic equation. Right, Colin, do you have the quadratic equation in general form?
Not yet.
Okay. Okay, have you got it now, Colin?
It's 4x squared minus 24x plus 20.
Okay, very good. 24x plus 20. So once you get there, you can see there's GCF. Okay, so remember you can take GCF out and then factor. Okay, so you should get two answers. Please check both answers. And keep the ones that work, okay? Could be one, could be two, or none, okay? Maybe both of them doesn't work. Okay, once you finish checking and got your final conclusion, please raise your hand. Okay, Eric, have you finished factoring?
Not yet.
Can you tell me how right now? How do you factor this?
Well, I have 2x.
Oh, you take GCF out. Take GCF out. You know what?
Okay. Yeah, I forgot about that.
Yeah, it makes it easier, okay, to factor. What's a GCF, Eric?
4.
Yeah, what's left?
X squared minus 6x plus 5.
Yeah, Continue.
And x minus 1 times x minus 5.
Yeah. Okay. Right, so from here we can see x equal to 5 and 1, right? And then how about checking? Aaron, which one do we keep?
I got both of them.
Both of them? Okay. Colin, how about you? What do you think? Do we keep both of them?
Same thing.
Yeah. Brennan,
Yep, both.
you sure?
Yeah.
Yeah, okay, so we keep both of them, okay? So remember to plug it back into the original question up there, okay, to check. When you do checking, okay, and then make sure the left side equal to the right side. All right, so let's call it a day. Next week will be our last class, and we'll be doing our first chapter, okay? Pretty easy chapter. And then after that, we can finish the class a bit earlier, huh? And remember, if you are coming for the summer, it's tomorrow at 12:20. Okay, bye-bye.
Bye.
Bye.
Bye, Jason.
Bye-bye.